Let's take up sulfur dioxide. First we are taking preparation of sulfur dioxide. Sulfur dioxide is formed by combustion of sulfur in presence of oxygen. It gives sulfur dioxide gas. In laboratory, if we want to prepare sulfur dioxide, we can take a suitable sodium sulfite, suitable salt of sulfite ion, sodium sulfite, which will be reacted with dilute sulfuric acid. We will get sulfur dioxide and salt water will be formed. So sulfite ion from the salt will react with dilute sulfuric acid, H ion from dilute sulfuric acid forming water and sulfur dioxide gas. Industrially, it is produced as a byproduct of roasting of sulfide ores. This is iron pyrite which when oxidized in the presence of oxygen, we get ferric oxide plus sulfur dioxide gas is formed. So as a byproduct of roasting of sulfide ores, sulfur dioxide can be manufactured. Another method for preparing sulfur dioxide is by heating sulfur with concentrated sulfuric acid. Concentrated sulfuric acid is a good oxidizing agent. It will oxidize sulfur to sulfur dioxide and also itself will get reduced to sulfur dioxide. So sulfur on heating with concentrated sulfuric acid gives 3 moles of sulfur dioxide plus 2 moles of water. We can also prepare sulfur dioxide by heating metals like copper or silver with concentrated sulfuric acid. Copper does not react with dilute sulfuric acid because it is less reactive than hydrogen. But with concentrated sulfuric acid, copper reacts and undergoes redox reaction. Copper gets oxidized to copper oxide which reacts with sulfuric acid to form copper sulfate and sulfuric acid gets reduced to sulfur dioxide. So we get copper sulfate plus sulfur dioxide plus 2 water are formed. Similarly, silver does not react with dilute sulfuric acid because it is less reactive than hydrogen. But silver reacts with concentrated sulfuric acid and undergoes oxidation to form silver oxide which reacts with sulfuric acid to form silver sulfate plus 2 water plus SO2 is formed. By roasting of sulfide ores, zinc plenty if roasted in presence of oxygen, we get zinc oxide plus sulfur dioxide. In this reaction, we are reducing calcium sulfate with the carbon. We will get calcium oxide plus sulfur dioxide plus carbon dioxide. Let's take up physical properties of sulfur dioxide. Sulfur dioxide is a colorless gas with pungent smell of burning sulfur and it's highly soluble in water. It liquefies at room temperature under a pressure of 2 atmosphere and boils at 263 Kelvin. It is heavier than air because its molecular weight is 64. It can be easily liquefied to colorless liquid at minus 10 degrees centigrade and into snow-like solid at minus 76 degrees centigrade. The molecule of sulfur dioxide undergoes sp2 hybridization and its bent shape or V shape or angular molecule. It is resonance hybrid of 2 resonating structures. These are 2 resonating structures. Here we have p-pi d-pi bond. Sulfur is using one paired electron in d orbital and oxygen is using unpaired electron in p orbital and this pi bond is called p-pi d-pi bond. And this is the usual p-pi bond. This is a lone pair of electrons and sulfur undergoes sp2 hybridization. In second resonating structure, this becomes p-pi bond and this is p-pi d-pi bond. Lone pair is acetate. These are 2 canonical forms whose resonance hybrid is this one. Here we have got these bonds have equal bond lengths. So if you are asked why SO bond in sulfur dioxide have equal bond length, so answer is it is due to resonance. And equal bond length is 143.1 picometer. And the bond angle in sp2 hybridization is normally 120, but in sulfur dioxide bond angle is 119 due to the presence of lone pair of electrons. Chemical properties. Sulfur dioxide when passed through water forms a solution of sulphurous acid. SO2 plus water gives H2SO3 aqueous. This is called sulphurous acid. It reacts readily with sodium hydroxide solution forming sodium sulfite, which then reacts with more sulfur dioxide to form sodium hydrogen sulfide. 2NaOH reacts with SO2 to form Na2SO3 plus water. If excess of SO2 is passed through aqueous solution of sodium sulfite, it results in the formation of sodium hydrogen sulfite, which is popularly called sodium bisulfite. Sulfur dioxide reacts with chlorine in presence of charcoal, which acts as a catalyst to give sulphuryl chloride. SO2 plus Cl2 will give you sulfur SO2Cl2 liquid, which is sulphuryl chloride, and it's a good chlorinating agent. Sulfur dioxide can be oxidized in presence of vanadium pentoxide as a catalyst at 770 Kelvin to give sulfur trioxide, which is used for manufacture of sulphuric acid. This is the second step of contact process, which is used for manufacture of sulphuric acid. When moist, sulfur dioxide behaves as reducing agent. For example, it can convert ferric ion, that is iron 3 ion, to ferrous ion, that is iron 2 ions, and decolorizes acidified potassium permanganate solution. Ferric ion, when reacts with sulfur dioxide in presence of water, they get reduced to ferrous ions. Sulfur dioxide gets oxidized to sulfate ion plus H ions are formed. Similarly, sulfur dioxide, when passed through acidified solution of KMnO4, it gets oxidized to sulfate ion plus H ion plus Mn plus 2 is formed, that is, it gets decolorized. Here, important point is to be noted that we take acidified KMnO4, but H ion appear on the product side because in the beginning small amount of sulfuric acid is added and sulfuric acid formed is more, therefore H ion come on the product side. Same is the case with this reaction where sulfuric acid is formed and H ions come on product side. Sulfur dioxide is non-supporter of combustion, but if magnesium ribbon, a burning magnesium ribbon is brought in the sulfur dioxide gas, it keeps on burning. Reason is that sulfur dioxide breaks into sulfur and oxygen and we get magnesium oxide plus magnesium sulfide is formed. That is, so it keeps on burning. In the same manner, potassium reacts with sulfur dioxide to form potassium sulfite and potassium thiosulfate. Thermal decomposition. At 1200 degrees centigrade, sulfur dioxide decomposes to sulfur and sulfur trioxide is formed. This is disproportionation reaction because sulfur in +4 oxidation state gets oxidized to +6 oxidation state and gets reduced to 0. In elemental state, sulfur has oxidation state 0. Acidic nature, it is a acidic oxide. It dissolves in water forming sulphurous acid. SO2 plus water gives sulphurous acid. Barium oxide, being basic in nature, reacts with sulfur dioxide to form barium sulfite. NaOH, when reacts with SO2, sodium hydrogen sulfite is formed. But if 2NaOH reacts with sulfur dioxide, we get sodium sulfite plus water. Sodium carbonate, when reacts with sulfur dioxide plus water, we get sodium hydrogen sulfide plus carbon dioxide gas is evolved. Sulfur dioxide is also, like carbon dioxide, turns lime water milky. Why it turns lime water milky? Because calcium hydroxide, which is lime water, reacts with sulfur dioxide to form white precipitate of calcium sulfite plus water is formed. If excess of sulfur dioxide is passed, this milkiness disappears due to the formation of calcium hydrogen sulfite, which is soluble in water. So this reaction is similar to carbon dioxide. So if you want to differentiate between CO2 and SO2, then CO2 is colorless and odorless gas, whereas sulfur dioxide is pungent smelling gas. Second difference is that sulfur dioxide turns acidified dichromate paper green, whereas carbon dioxide does not. Addition reactions. Sulfur dioxide reacts with chlorine to form sulphuryl chloride. Sulfur dioxide reacts with oxygen to form sulfur trioxide in presence of catalyst vanadium pentoxide. Lead dioxide reacts with sulfur dioxide to form lead sulfate. Reducing nature. Sulfur dioxide can act as both oxidizing as well as reducing agent because its oxidation state is +4. It can go to higher as well as lower oxidation state. Water dissolves sulfur dioxide resulting in the formation of sulphurous acid. Sulphurous acid, can get oxidized by water to form sulfuric acid, and nascent hydrogen is formed, due to which it acts as reducing agent. So sulfur dioxide in aqueous solution of chlorine gets oxidized to sulfuric acid plus 2HCl is formed. Gets oxidized means it acts as a reducing agent. Acidified KMnO4 also is a strong oxidizing agent which oxidizes sulfur dioxide to sulfate K2SO4, 2MnSO4 plus 2 moles of sulfuric acid is formed. That is, sulfur dioxide when passed through acidified KMnO4, it decolonizes potassium permanganate solution because it reduces KMnO4 to MnSO4. Sulfur dioxide turns acidified dichromate paper green. Potassium dichromate orange color solid K2Cr2O7 plus 3 moles of sulfur dioxide in presence of sulfuric acid we are passing. K2SO4 will be formed, Cr2SO4 whole thrice will be formed, which is green in color, plus water will be formed. So in this reaction also sulfur dioxide is reducing agent, K2Cr2O7 in presence of H2SO4 acts as oxidizing agent. Ferric sulfate gets reduced to ferrous sulfate with the help of aqueous solution of sulfur dioxide plus 2H2SO4 is formed. Potassium iodate can be reduced to iodine with the help of sulfur dioxide in aqueous solution, plus you will get K2SO4 and sulfuric acid will be formed. So in all these reactions, sulfur dioxide in aqueous solution is acting as reducing agent. It also acts as oxidizing agent. If H2S reacts with sulfur dioxide, we get colloidal sulfur and water is formed. In this reaction, sulfur dioxide is an oxidizing agent, H2S is reducing agent. Now, magnesium reacts with sulfur dioxide. It gives magnesium oxide and magnesium sulfide. Here, sulfur dioxide is acting as oxidizing agent, magnesium is acting as reducing agent. Potassium reacts with sulfur dioxide to form potassium sulfite and potassium thiosulfate. Here SO2 is oxidizing agent, potassium is reducing agent. Exactly in the same way, iron reacts with sulfur dioxide to form ferrous oxide and ferrous sulfite. SO2 acts as reducing agent. CO is unstable. It gets easily oxidized by sulfur dioxide to form carbon dioxide and sulfur is formed. So SO2 gets reduced to sulfur in this case. Similarly, SO2 gets reduced by hydrogen to form water and sulfur is formed. So here hydrogen is reducing agent, SO2 is oxidizing agent. SnCl2 gets oxidized as sulfur dioxide in presence of hydrochloric acid to form SnCl4 plus water plus sulfur is formed. Mercurous chloride gets oxidized to mercury chloride by sulfur dioxide in presence of HCl, so plus water plus sulfur is formed. Bleaching action. Sulfur dioxide acts as bleaching agent in aqueous solution. So when it is dissolved in water, it produces sulphurous acid and nascent hydrogen is produced. This nascent hydrogen reduces colored matter to colorless matter. Means sulfur dioxide bleaches by reduction. And the colorless matter which is obtained when comes in contact with air or oxidizing agent, it gets oxidized and forms colored substance again. That is the reason that SO2 is temporary bleaching agent. Whereas chlorine is permanent bleaching agent because chlorine bleaches by oxidation. And once the colored substance is oxidized to colorless substance, it cannot regain its color back. SO2 is temporary bleaching agent, Cl2 is permanent bleaching agent. SO2 bleaches by reduction, chlorine bleaches by oxidation. Uses of sulfur dioxide, it is used in refining of petroleum and sugar. Sulfurless sugar means where sulfur dioxide has not been used as bleaching agent. In bleaching wool and silk as an anti-chlor. Anti-chlor means it removes chlorine. It acts as disinfectant and preservative. Sulfuric acid, sodium hydrogen sulfite, calcium hydrogen sulfite, which are industrial chemical, are manufactured from sulfur dioxide. Liquid sulfur dioxide is used as solvent to dissolve number of organic and inorganic chemicals.